Okay, let's unpack this. Today, we're diving into a topic that underpins much of our daily safety, yet remains largely unseen.
Right.
We're talking about the intricate world of fire safety codes. Specifically, we're peeling back the layers of NFPA 1, the fire code.
That's the big one.
Exactly. You might not actively think about it, but these codes are silently at work, protecting us in nearly every building and public space we inhabit.
Hmm.
It's a huge, detailed document, but our mission today is to cut through the complexity. We want to extract the most important nuggets of knowledge and insight for you.
Yeah, make it digestible.
Right, with surprising facts and just enough humor, hopefully, to keep you hooked.
Precisely. And NFPA 1, it really reflects the deep technical knowledge of countless experts.
Mm-hmm.
All that expertise kind of distilled into one comprehensive set of guidelines and mandates, really.
Uh-huh.
It's intended to provide state, county, local jurisdictions with an incredibly effective fire code. It acts as a foundational blueprint for safety across, well, all sorts of different environments.
So, our goal here in this deep dive is to demystify these regulations,
Hmm.
help you understand not just what they are, but critically, why they exist and what they actually mean for your everyday safety.
Yeah, think of it as a shortcut. A shortcut to being well-informed about this invisible safety net that's all around us.
Kicking us off, let's talk about a crucial player in this whole intricate system.
Yeah.
The authority having jurisdiction, or AHJ for short.
Yep, the H shape.
When you hear that term, it might sound like one specific person, maybe like a fire chief, but it's actually quite a broad definition, isn't it?
It truly is. It's broader than you might think. The NFPA defines the AHJ as an organization, office, or individual responsible for enforcing the requirements of a code or standard,
Okay.
or for approving equipment, materials, and installation, or a procedure. So you see, depending on where you are, what the project is,
Uh-huh.
the AHJ could be your local fire marshal, sure, but it could also be a building official in your city, maybe even a specific local government agency.
Right.
They are the entity with the final say. The final word on whether something, a design, an installation, an operational procedure, meets the fire safety standards.
So they're the ultimate arbiters.
In essence, yes. They ensure these life-saving rules aren't just like sitting on paper,
Yeah.
but actively applied and adhered to in the real world.
So what kind of power does this AHJ actually wield? It sounds like they hold a lot of sway in making sure things are done right.
They absolutely do. And their authority is pretty comprehensive. For instance, the AHJ has the power to demand plans and specifications from anyone undertaking work.
Before they even start.
Before construction even begins, yeah. On a new building, major renovation, they have to approve all the proposed installations first. Got to make sure they meet the necessary codes and standards.
Yeah.
Imagine a new skyscraper project. If the fire safety plans aren't approved by the AHJ, that building simply isn't going to get built, period.
Wow.
And their power isn't just about the initial design. It extends right into the construction process itself.
How so?
Well, if something critical has been covered up or concealed during installation without first being inspected.
Like hidden wiring or pipes?
Exactly, like a fire-rated wall or a sprinkler pipe hidden in a ceiling. If it wasn't inspected first, the AHJ has the authority to require that such work be exposed for inspection.
So they can make them tear things out.
They can. It's a critical power. It prevents dangerous shortcuts or, shoddy work from being hidden behind walls or under flooring.
Right.
It's a proactive measure to stop potential hazards from being built right into a structure. Ensures those often hidden bits meet the standards before they're operational.
That makes perfect sense. It's like an audit for safety that can happen at any stage, really. But what if someone doesn't play by the rules? What are the actual consequences for non-compliance?
Well, the code provides very clear enforcement mechanisms,
Mm.
and these are crucial for maintaining its integrity.
Mm-hmm.
If the AHJ determines violations of this code, they can issue written notice. This isn't just a casual chat.
Right, it's formal.
It's a formal, legal document. It can be served personally, sent by mail, or delivered to a person of responsibility upon the premises.
Okay.
And beyond that, the AHJ is also permitted to revoke or suspend a certificate of fitnesses.
A certificate of fitness. What's that exactly?
Good question. It's a written document granting permission to such person to conduct or engage in any operation or act for which certification is required.
Ah, so like for specialized work.
Exactly. Maybe operating certain hazardous equipment or performing specialized fire protection work. If you hold such a certificate, you are legally required to produce it upon request
To who?
to anyone you're providing services for, or, of course, to the AHJ.
Hmm.
And they can pull that certificate if they find a violation during inspection, or even if you submitted false statements or misrepresentations in your application.
Wow.
Yeah, this system highlights the stringent accountability built right in. Ensure those responsible for fire safety are qualified, honest, diligent.
It's a powerful incentive for compliance.
Definitely. Ultimately protects the public.
Wow, so the AHJ really is the ultimate guardian of public safety in these situations, but with that much authority, especially when their decisions can have huge financial implications for property owners, developers.
Hmm.
Do they face any personal liability? Or does the code offer them some kind of protection when they're making these tough calls?
That's a really interesting point, and what's truly fascinating here is that the code explicitly addresses liability. It recognizes the challenging, often high-stakes nature of these duties.
Okay.
It states that the AHJ and other individuals charged with official duties like, controlling fires or enforcing the code,
Mm-hmm.
if they are acting in good faith and without malice in the discharge of their duties, shall not thereby be rendered personally liable for any damage that might occur to people or property because of what they did or maybe didn't do.
So they're protected if they're acting in good faith.
Yes. And furthermore, the code goes a step further. Any lawsuit brought against them for such acts shall be defended by this jurisdiction until final termination, and any judgment resulting therefrom shall be assumed by this jurisdiction.
So the local government backs them up.
Exactly.
Yeah.
And this protection is absolutely critical because enforcing these codes often involves making difficult, sometimes unpopular decisions.
Right, decisions that cost people money.
Big money or major operational changes. This legal shield lets them prioritize public safety without fearing personal lawsuits. It promotes more effective, impartial enforcement.
Yeah, I can see that. Without it, they might hesitate.
Exactly. Fear of litigation could lead to weaker enforcement and ultimately less safe buildings, so that protection is key.
That's a really important distinction, and it highlights the seriousness of their role. Now, let's talk about some fundamental terms that are sprinkled throughout this entire document. Things like code versus guide, they sound pretty similar, but I gather there's a huge difference legally, right?
Oh, a very important distinction, and one that often causes confusion even for folks who deal with regulations.
Mm.
A code is defined as a standard that is an extensive compilation of provisions covering broad subject matter, or that is suitable for adoption into law independently of other codes and standards.
Okay, so suitable for adoption into law. That's the key part.
That's the key. Think of it as a set of mandatory rules.
Mm.
Once a local jurisdiction adopts it, it carries the full force of law.
So if you don't follow a code.
You're breaking the law. Simple as that.
Okay, and a guide.
In stark contrast, a guide is advisory or informative in nature, and that contains only non-mandatory provisions.
Ah, non-mandatory.
Right. While a guide might offer invaluable best practices or insights, the document as a whole is not suitable for adoption into law.
Got it.
So to simplify, code, think must-do legally enforceable requirements. Guide, think good practice to consider valuable recommendations, but not legally binding.
That's a super clear distinction. Very helpful. What about approved and labeled? They seem like they could be synonyms, but I suspect they have different meanings here too.
They absolutely do, and the difference matters for compliance. Approved simply means acceptable to the authority having jurisdiction.
So the AHJ just says, okay.
Pretty much.
Yeah.
It's the AHJ giving the final nod to something, a design, a procedure, a piece of equipment, after they've personally reviewed it and decided it's okay.
Right.
Labeled, however, is more specific. It usually involves independent third-party verification, which is a huge efficiency booster for everyone.
How so?
Well, labeled refers to equipment or materials to which has been attached a label, symbol, or other identifying mark of an organization that is acceptable to the authority having jurisdiction,
Okay.
and concerned with product evaluation that maintains periodic inspection of production of labeled equipment or materials, and by whose labeling the manufacturer indicates compliance with appropriate standards or performance in a specified manner.
Wow, that's a mouthful. So it means tested by someone else.
Yeah. Exactly. Tested and certified by a recognized impartial organization like UL Underwriters Laboratories.
Right, oh, you will.
And that organization actually performs periodic inspections of the manufacturing process, too, to ensure ongoing compliance.
Ah, so it's not a one-time thing?
Nope. It offers an extra, consistent layer of assurance for the AHJ, They don't have to personally vet every single fire extinguisher or smoke detector.
They can trust the label.
They can trust a reputable labeling organization's consistent oversight and rigorous testing. It's much more efficient for ensuring widespread safety.
So the AHJ doesn't have to personally vet every single piece of equipment. They can rely on reputable labeling. That's a clever system, very efficient. Okay, let's talk about fire hazard. It seems like a very broad term. Does it cover more than just active flames?
Indeed it does. It's incredibly broad and deliberately so. A fire hazard is defined as any situation, process, material, or condition that, on the basis of applicable data, can cause a fire or explosion. Or they can provide a ready fuel supply to augment the spread or intensity of a fire or explosion, all of which pose a threat to life or property.
So it's not just about flames, it's about potential.
Exactly. Anything that could lead to a fire or explosion, or that could make an existing one worse. And importantly, it has to pose a threat to life or property.
Hmm.
This is why you see rules about seemingly innocuous things, how chemicals are stored, the placement of Christmas trees, even the accumulation of dust in certain factories.
Gust. Really?
Oh yeah, certain types of dust can be highly explosive. The code takes a very wide view of what constitutes a hazard to ensure all potential risks, even the subtle ones, are considered and mitigated.
That really expands the scope of what needs to be considered for safety. It's kind of fascinating and a bit terrifying. And speaking of safety, means of egress. Sounds like a fancy term for exits. Is it more than just the exit door itself?
It is, much more. It's far more encompassing than just the door you walk through to get outside.
Mm.
The means of egress isn't simply the final exit point. It comprises the vertical and horizontal travel.
Vertical too, like stairs.
Yep. Stairs, elevators, escalators,
Yeah.
and includes intervening room spaces, doorways, hallways, corridors, passageways, balconies, ramps, enclosures, lobbies, horizontal exits, courts, and yards.
Wow, so it's the entire
The
path.
entire continuous path from anywhere in a building to a safe public way outside. And critically, the code explicitly states, in every occupied building or structure, means of egress from all parts of the building shall be maintained free and unobstructed.
Free and unobstructed always.
Always. Clear pathways, no boxes in the hallway, no furniture blocking a doorway, no locked doors along the escape route.
Okay.
It's about ensuring a rapid, safe, and unhindered escape route for everyone under any circumstances, from wherever they are, all the way out.
Yeah, you see those marked exits everywhere, clear paths in stores.
That's the principle in action. It makes you look at a building differently, doesn't it? Knowing every single step of that path is designed for your escape.
It really does, knowing that every part of that path is the means of egress.
Yeah, new perspective. And there are so many different types of occupancies defined in this code. Can you give us a few examples? Why are these distinctions so important? Because an office building is clearly different from, say, a hospital or a warehouse.
Absolutely. The code categorizes buildings or even parts of them by their primary use. And these classifications are fundamental. They dictate vastly different specific safety requirements based on the inherent risks associated with that use.
Makes sense.
For example, a residential board and care occupancy. That's defined as a building or portion thereof that is used for lodging and boarding of 4 or more residents, not related by blood or marriage to the owners or operators for the purpose of providing personal care services.
Okay, like a group home.
Exactly. And a crucial note specifies this includes group housing arrangement for physically or mentally handicapped persons, maybe preparing for independent living. This highlights how specialized the codes get for vulnerable populations.
So they need extra safety measures. Enhanced measures, yeah.
Okay.
Maybe more staff assistance for evacuation, different alarm systems.
Okay.
It goes beyond a general residential occupancy, which just provides sleeping accommodations for purposes other than healthcare or detention and correctional.
Right, the risks are different.
Very different. An apartment building versus a facility caring for folks with limited mobility or cognitive issues.
Hmm.
Huge difference in evacuation needs.
Okay, what else?
Then you have things like storage occupancy, used primarily for the storage or sheltering of goods, merchandise, products, vehicles, or animals.
Warehouses.
Warehouses, yes, but this broad category includes more specific types, like a mini storage building.
Self-storage places.
Yep. Defined as a storage occupancy partitioned into areas that are rented or leased for storing personal or business items with specific conditions. Like maybe the fire barriers between units are less robust and the items are concealed from view from outside the unit.
Ah, so firefighters don't know what's inside.
Exactly. That distinction is vital. The fire load, the accessibility, very different from a general warehouse. Or think about an industrial occupancy where products are manufactured or in which processing, assembling, mixing, packaging, or repair operations are conducted.
Factories.
Right. Each of these occupancies presents unique fire risks. The materials involved, the processes generating heat or sparks, the number and capabilities of occupants.
So the occupancy type drives the specific rules.
Understanding the classification is crucial. Different occupancies need different protective measures, sprinkler density, exit signage, emergency planning. It's foundational for tailored fire safety. A one-size-fits-all approach just wouldn't work.
So the AHJ is the ultimate enforcer. But beyond them, who else carries the weight of responsibility in maintaining fire safety, especially during construction and in daily operations? It sounds like it's shared.
You're absolutely right. The responsibility is definitely shared across multiple stakeholders.
Okay.
It doesn't all fall on the AHJ.
Oh,
But
right.
once a project is underway, the person performing the work,
Yeah.
the contractor, the installer,
Mhm.
they have a critical responsibility. They must notify the AHJ when the installation is ready for a required inspection.
So they have to call for inspections.
They do. It's vital for ensuring compliance at critical stages.
Mm.
It prevents issues from being hidden or forgotten and lets the AHJ verify work before it's covered up.
Shifts the burden of communication.
Exactly. Puts it on those doing the actual construction.
And during an actual emergency, when chaos might reign, who takes charge? Is there a clear chain of command set up by the code?
Absolutely. Clear command is essential in a crisis. During any emergency, including the investigation afterwards, the incident commander or authorized representative shall be permitted to control or prohibit the approach to the scene by any vehicle, vessel, or person.
So they can clear the area.
Total control. It grants immediate sweeping authority to the designated incident commander, usually the ranking fire chief or their rep. Manage the chaos, ensure operations aren't hindered.
Makes sense.
And the code is strict. No person shall obstruct the operations of the fire department or disobey any command of the incident commander.
Don't get in their way.
Basically, yes.
Yeah.
It underscores the absolute authority given to emergency responders. Establish clear command and control when seconds count. Overrides individual preferences for the greater public safety.
That makes perfect sense. Clear authority is essential. What about the initial planning and documentation for a new project? Who ensures fire safety requirements are properly included from the get-go, before ground is even broken?
The applicant, typically the property owner or the developer, shall be responsible to ensure several key conditions are met right from the start.
Like what?
Well, first, ensuring that the construction documents include all of the fire protection requirements. So, fire safety isn't an afterthought. It's baked into the core design.
Integrated from the start.
Right. They're also responsible for ensuring that the shop drawings are correct and in compliance with the applicable codes and standards.
Shop drawings. Those are the super detailed plans.
Exactly. For specific components, like how the sprinkler system is laid out or how fire doors are installed, their accuracy is paramount.
Got it.
And, crucially, the applicant must ensure that the contractor maintains an approved set of construction documents on site
Why on site?
for accountability and to ensure the original design intent for fire safety is carried through to construction. It needs to be accessible during the work itself for workers and inspectors. It shows fire safety as a continuous thread from concept right through to completion.
Now, this next section is where things get really interesting, I think. Most people, myself included, think of fire codes as a rigid set of rules. Do X, Y, and Z.
Right, the checklist approach.
Yeah. Install a certain sprinkler type at specific intervals, use a particular fire-rated door, that sort of thing. But this document introduces something called a performance-based option. What exactly is that, and why would someone choose it over the traditional way?
That's a great question because it represents a significant evolution in fire safety engineering. Traditionally, codes are indeed prescriptive. They tell you exactly how to achieve safety. Install the sprinkler every 10 feet, build a wall with a 2-hour rating.
Right.
A performance-based option outlined in Chapter 5 allows for much greater flexibility and, frankly, innovation.
How does it work?
Instead of prescribing how you must achieve safety, it focuses on what safety outcomes must be achieved. The core idea is to establish acceptable levels of risk for facilities.
Okay.
So you define the acceptable safety goals, like everyone gets out safely within X minutes, and then you demonstrate through rigorous analysis and engineering that your unique design achieves those goals, even if it doesn't follow the exact prescriptive steps.
Ah, so you prove your way works.
Exactly. This approach is often chosen for complex, unique, or very large buildings.
Mhm.
Places where a prescriptive approach might be too restrictive, maybe cost prohibitive, or just wouldn't account for the specific characteristics of the structure or its operations.
Like a very unusual museum or stadium.
Perfect examples. It allows for creative, often more efficient solutions that still deliver equivalent or sometimes even superior safety.
So it's about proving that your unique design hits the same safety targets even if it takes a different path. That sounds like it requires a lot more in-depth analysis and expertise than just checking boxes on a
Oh,
list.
absolutely. Way more involved. The performance-based design must meet the overarching goals and objectives of the code, no question. But it grants designers the freedom to innovate in how they get there.
Right.
This involves a rigorous, almost scientific process. The design itself has to be prepared by a person with qualifications acceptable to the AHJ.
Not just any engineer.
No, these qualifications aren't just a basic degree. They should include experience, education, and credentials that demonstrate knowledgeable and responsible use of applicable models and methods.
So real specialists.
Deep expertise in fire science and engineering. The ability to accurately model fire behavior, predict smoke movement, calculate evacuation times. It's far beyond just rote compliance. This ensures any alternative solution is genuinely safe, backed by sound, verifiable engineering.
That makes total sense. You can't just wing it when lives are on the line. How do they actually show the AHJ that their unique performance-based design works? Is it a mountain of paperwork, complex simulations, or what?
It's definitely a significant documentation effort. When submitted, the owner shall document in an approved format each performance objective and applicable scenario,
Okay.
including any calculation methods or models used in establishing the proposed design's fire and life safety performance. Think of it like a detailed scientific paper or an exhaustive engineering report,
Justifying the design.
thoroughly justifying it,
Yeah.
outlining all the assumptions, the methods used, the predicted safety outcomes. This documentation is absolutely crucial for the AHJ's review and approval.
Seems fair.
And what's also fascinating here and important is that the AHJ shall be permitted to require an approved, independent third party to review the proposed design.
At the owner's expense.
At the owner's expense, yes. This adds another vital layer of scrutiny, ensures impartiality.
Like a second opinion.
Exactly. Because the stakes human life, major property investment are so incredibly high. Having an independent expert validate the complex calculations and assumptions provides an essential safeguard, builds confidence in the proposed alternative.
So it's not just the designer saying, trust me.
No, it's about robust, peer-reviewed verification.
So what are the overarching goals these performance-based designs are actually trying to achieve? What are these performance objectives that guide such a detailed and flexible approach? Seems like more than just putting out fires.
Oh, much more. The objectives are clear and multifaceted, extending well beyond just fire extinguishment. Firstly, there's a huge emphasis on life safety,
Getting people out.
ensuring an acceptable level of safety for occupants, and that they have sufficient time to safely exit the facility during a fire or other emergency.
And that calculation must be complex.
It is. It's based on evaluating a whole array of factors.
Yeah.
The characteristics of the occupancy. Is it a busy office, a quiet library, a hospital? The capabilities of the occupants, hugely important for places like residential board and care facilities,
It's
right?
people with limited mobility.
Exactly. They also consider the number of persons exposed and the specific fire protection available in the building.
Mm-hmm.
And the code also explicitly emphasizes protecting emergency responders too, acknowledging the risks they face and designing systems that help them operate safely and effectively.
So it truly is a race against time for occupants to escape, isn't it? The code really seems to quantify that race.
It really does. The code notes that escaping the harmful effects of fire or mitigating them is effectively a race against time.
Right.
So when designers use these sophisticated computer models, fire dynamics, simulation, evacuation modeling, to predict how a fire will develop and how long it will take to make a space untenable, basically, too hazardous to survive, the AHJ evaluates the margin of safety.
The buffer zone.
Exactly. They're literally asking, is there sufficient time to get everyone out safely with a good buffer?
And if the buffer isn't big enough?
Well, if the AHJ feels the predicted escape time is too close to the predicted time of untenability, maybe the margin is too slim,
Yeah.
then the AHJ can impose a greater margin of safety than the designer originally proposed,
Meaning back to the drawing board.
potentially. The designer would have to modify the design to provide even more time for evacuation, ensure a robust buffer for unforeseen issues or slower evacuations. This where that cutting-edge engineering analysis meets real-world public safety needs.
Beyond just getting people out safely, what else are they protecting with these performance-based designs? It sounds like there's a broader scope than just preventing direct fire damage to people.
Indeed, the scope is quite broad. It reflects a truly holistic view of safety. The design also aims to provide an acceptable level of safety for occupants and for individuals immediately adjacent to the property.
Neighbors, basically.
Right. Protection from the effects of an unauthorized release of hazardous materials or the unintentional reaction of hazardous materials. So, containing chemical risks within the building, preventing off-site impacts.
Okay, hazmat too.
Yep. Then there's property protection, ensuring the design limits damage to the building itself and its contents from fire, smoke, water,
Protecting the investment.
protecting the investment, structural integrity, all that, and for facilities serving a public welfare role.
Like critical infrastructure.
Exactly. Power plants, water treatment facilities, essential government buildings. The design must limit effects that could cause an unacceptable interruption of the facility's mission.
Keep the lights on, keep the water flowing.
Pretty much. This broad view ensures a comprehensive approach. Considers the building, occupants, surroundings, critical functions, societal contribution.
How do designers actually test or prove their performance-based designs work? Do they run complex computer simulations, or is it more theoretical on paper?
Oh, they absolutely use specific fire design scenarios. They model potential incidents to demonstrate the effectiveness of their solutions.
Like what-if scenarios?
Exactly. And these aren't just generic, they're very specific, challenging what-ifs. For example, fire design scenario 2 involves an ultra-fast developing fire in the primary means of egress, with interior doors open at the start of the fire.
Wow, that sounds bad. Main exit blocked quickly.
Right. This scenario is designed to address that critical concern. What happens if the main escape routes are quickly compromised? It directly evaluates how reducing available exits impacts occupant safety.
Okay.
Another critical one is fire design scenario 3. This involves a fire that starts in a normally unoccupied room that can potentially endanger a large number of occupants in a large room or other area.
So like a fire starting in a closet affecting an auditorium?
Precisely. It helps evaluate how a seemingly innocuous starting point could rapidly escalate and impact a highly populated space. Ensures even hidden dangers are accounted for.
So they're preparing for worst-case scenarios, even the hidden ones. And how do they account for the inherent unknowns and variables in a real-world fire? Because you can't predict absolutely everything, can you?
Precisely. They're trying to anticipate not just the obvious, but the less apparent, maybe cascading failures.
Yeah.
And to your point about unknowns, throughout this entire design process, approved safety factors shall be included in the design methods and calculations.
Building in a cushion.
Exactly. This is explicitly to reflect uncertainty in the assumptions, data, and other factors associated with the design. Fire science is advanced, but still involves variables you can't predict with absolute certainty.
Like how people will react?
How people react, how specific materials might burn under unique conditions.
Yep.
So these safety factors provide a crucial buffer, a margin for error.
Makes sense.
In all aspects of the design, initial concepts, final calculations shall be documented. The format and content shall be acceptable to the AHJ. Ensures transparency, reproducibility, accountability, lets the AHJ really dig into the engineering.
It sounds like a continuous process even after the building is occupied and the initial design is approved. Does the code require ongoing diligence from the building owner to maintain that performance level?
It is absolutely a continuous process, not a one-and-done deal at all. The design specifications and O&M manual documentation, operations and maintenance,
Right.
that documentation should provide a guide for the facility owner and tenants to follow in order to maintain the required level of safety anticipated by the original design.
So everyone knows how to keep it safe.
It's not just about getting the certificate of occupancy and then forgetting it. It's about ensuring ongoing safety. The AHJ also uses this documentation to guide their continuous oversight, their inspections.
Right.
It emphasizes that performance-based design is a living document, requires continuous management, verification, making sure the safety levels achieved during design are maintained throughout the building's operational life. It's a dynamic responsibility for the owner.
We've covered the foundations and how buildings are designed for safety, both prescriptively and performance-based. Now let's zoom in on what many people instinctively think of as the biggest fire threat: flammable and combustible liquids and gases. This code must go into incredible detail here.
Oh, absolutely. Here's where it gets really interesting and very specific,
Right.
because the code drills down into precise quantities and scenarios, recognizing the immense danger these materials pose.
Right.
The first thing to note is the extensive list of activities and storage quantities that require permits. It's quite eye-opening.
Like what sort of things need a permit?
Well, for instance, you need a permit to use or operate, repair, or modify a pipeline for the on-site transportation of flammable or combustible liquids, even just moving it around on your own property. Furthermore, you need a permit to store, handle, or use Class I liquids. Think highly volatile stuff like gasoline, ether,
Mm-hmm.
even if it's just over 5 gallons inside a building or 10 gallons outside.
That's not very much.
It's really not.
Yeah.
And for the less volatile but still dangerous Class 2 or Class 3 liquids like diesel fuel, kerosene, oils,
Yeah.
a permit is needed if you exceed 25 gallons in a building or 60 gallons outside. These seemingly small quantities can become major hazards if not properly managed, hence the strict permit rules.
So even relatively small amounts can trigger a permit requirement. That's surprising. Are there any common exceptions, or is it pretty much universal?
Yes, thankfully there are practical exceptions, to avoid overburdening everyday stuff that poses minimal risk.
Right.
For example, a permit is generally not required for the storage or use of Class I liquids in the fuel tank of a motor vehicle, aircraft, motorboat.
Mm.
You get the idea.
Yeah.
Unless the AHJ specifically thinks it would cause an unsafe condition.
Okay, the fuel in your car is fine.
Usually, yes. Similarly, paints, oils, varnishes, or similar flammable mixtures stored for maintenance, maybe for not more than 30 days, might also be exempt for normal operations.
But beyond that.
Beyond that, the scope of activities that do require permits is vast and highly specific. As soon as you're doing something like installing, constructing, altering, or operating tank vehicles, equipment, tanks, plants, terminals, wells, fuel dispensing stations, refineries,
Basically anything industrial scale.
anything where flammable or combustible liquids are produced, processed, transported, stored, dispensed, or used commercially or industrially. The same applies if you want to remove Class 1 or Class 2 liquids from an underground storage tank, by any means other than the approved stationary on-site pumps.
So no siphoning without approval?
Pretty much. Or even to change the type of content stored in a flammable or combustible liquid tank to something it wasn't designed for.
Ah.
This demonstrates the incredibly granular control needed, recognizing the severe consequences if these substances are mishandled.
That's an astonishing number of scenarios needing permits. What about the physical storage conditions? It's not just about quantities, but literally how and where they're kept.
Exactly. When it comes to physical storage, the regulations are very precise to minimize risk. For instance, storage of Class 1 and Class 2 liquids or gasolines, diesels, shall not exceed 60 gallons within 50 feet of a structure.
Creating a buffer zone.
A clear buffer zone, ensuring that if there's a spill or fire, it's not immediately next to a building. And critically, storage areas shall be kept free of weeds, debris, and combustible materials not necessary to the storage.
Keep the area clear of extra fuel.
Right. Minimize anything else that could contribute to a fire. For compressed gases, there's an important cautious assumption. Containers, cylinders, and tanks containing residual product shall be treated as full,
Even if they seem empty.
even if they seem empty, unless they are actively being examined, serviced, or refilled by a gas manufacturer or distributor. This is vital because even small amounts of residual gas can be hazardous, released under pressure.
So treat it like it's full.
Safer to assume the worst, yes.
And they need pressure relief. That seems fundamental for gases stored under pressure to prevent explosions.
Absolutely. Critical safety feature. Pressure relief devices shall be provided to protect containers and systems containing compressed gases from rupture in the event of overpressure from thermal exposure.
From heat, basically.
Yeah, heat-induced pressure buildup. This is a critical engineering control, preventing catastrophic failures like an explosion.
Okay.
For LP gas specifically, that's your common propane, the code says the storage, use, and handling shall comply with the requirements of this chapter and also integrate with NFPA 58.
The specific LP gas code.
Exactly. Shows how NFPA 1 works with other more specialized standards. And for larger LP gas installations, commercial sites, industrial plants,
Yeah.
plans for stationary installations utilizing stored containers of over 2,000 gallons individual water capacity, or with aggregate water capacity exceeding 4,000 gallons, and all rooftop installations shall be submitted to the AHJ before the installation is started.
More oversight for bigger risks.
The larger the volume, the higher the risk. The more oversight and upfront planning needed, because a failure there could be devastating.
Are there general prohibitions that apply across the board for these types of materials? Things that seem like common sense but need to be explicitly stated and enforced because, well, people forget or get complacent.
Yes, some common sense rules are indeed explicitly stated and vigorously enforced, because even simple actions can have catastrophic consequences with highly flammable stuff.
Like no smoking.
Exactly. Open flames and smoking shall not be permitted in flammable gas storage areas and generally in areas containing flammable liquids. Direct, absolute prohibition. No ignition sources near volatile materials.
Makes sense.
Also, welding, cutting, and similar spark-producing operations shall not be permitted in areas containing flammable liquids until a written permit authorizing such work has been issued.
The hot work permit.
Right. That process is crucial. It requires an inspection of the area to assure that proper precautions have been taken and will be followed until the job is completed.
So it's managed carefully.
Ensures high-risk activities only happen after a thorough safety check and with continuous vigilance. The same permit system applies elsewhere too, like lumber yards, for cutting, welding, or other use of open flames or spark-producing equipment. Acknowledges the significant fire load there. It's all about controlling those ignition sources.
What about how these liquids are moved around within a facility? Are there rules for that too? Preventing spills or sparks during transfer seems critical.
Definitely. The transfer process is just as critical as storage. Liquid shall be transported by means of closed containers, approved safety cans or approved portable tanks, or through a fixed piping system.
No open buckets.
Critically, open containers shall not be used for moving or storing liquids. Prevent spills, uncontrolled release of flammable vapors during transport.
Okay.
Whenever liquids are transferred from one container to another, pouring from a large drum into a smaller one, say,
Yeah.
both containers shall be effectively bonded and grounded to dissipate static electricity.
Ah, the static spark risk.
Vital measure. Prevents sparks from static discharge. You know that little zap you get sometimes. Imagine that igniting flammable vapor.
Yikes.
And for gravity flow systems, maybe supplying spray nozzles, the container supplying those nozzles shall not exceed 10 gallons capacity. These details illustrate the micro-level controls needed, preventing ignition, controlling spills during movement.
And if a container is damaged or starts leaking, what's the immediate protocol? You can't just leave it there dripping.
Right. If a container up to 60 gallons capacity is leaking or damaged, it shall be permitted to be stored temporarily, provided they're enclosed in overpack containers.
Like putting it in a bigger sealed tub.
Sort of, yeah. And the important bit is the overpack container must be made of the same material as the original container.
For chemical compatibility.
Exactly. Ensures proper containment. It's a practical, immediate solution for containing spills, prevents wider contamination or fire spread, allows time for proper disposal or repair without escalating the hazard. Pragmatic safety.
You mentioned electrical equipment in hazardous areas.
Right.
What's the general principle there? Electrical sparks are such a common ignition source, it seems vital to control that.
Absolutely. For areas where Class 1 liquids are stored or handled, or where Class 2 or 3 liquids are handled at or above their flash points, meaning they could easily produce flammable vapors.
Yeah.
The overarching principle is that any electrical equipment provided shall not constitute a source of ignition for the flammable vapor that might be present under normal operation or during a spill.
So explosion-proof equipment.
Often, yes.
Uh-huh.
Using specially designed explosion-proof or intrinsically safe equipment, certified not to produce sparks or heat capable of igniting vapors in those environments.
Got it.
The code specifies compliance with specific subsections, ensures this safety. You'll also see references like installation of electrical wiring shall meet the requirements of NFPA 30, emphasizing adherence to broader electrical safety codes tailored for these conditions. It's about designing electrical systems that are inherently safe in a flammable atmosphere, not adding fuel to the fire, literally.
I've heard terms like boil over or slop over in the context of large liquid fires, especially things like crude oil tanks. Are these specific phenomena defined? And why is understanding them important for firefighters?
Yes, they are defined, and understanding the distinctions is critical. They describe very different phenomena requiring different firefighting responses.
Okay.
A boilover is a specific, incredibly dangerous event. A burning, viscous liquid in a tank, like crude oil, heats up a layer of water at the bottom.
Water trapped underneath.
Right. That water suddenly flashes into steam, causing the hot, burning liquid to forcefully erupt and spill over the top of the tank.
Like a volcano of fire.
Pretty much.
Yeah.
Spreading the fire rapidly, potentially injuring responders. A severe, almost explosive event.
Wow. Okay, that's different from slop over.
Very different. A slop over is a minor frothing that occurs when water is sprayed onto the hot surface of a burning oil. Much less violent, mostly surface frothing. And a froth over isn't even associated with fire. It's when water enters a tank containing hot viscous oil, converts to steam, and causes contents to overflow without ignition.
Ah.
Understanding these nuances is critical for effective, safe emergency response. Guides firefighters to deploy the right tactics for each scenario. You definitely don't want to accidentally trigger a boil over by spraying water incorrectly.
Beyond general flammable liquids, the code addresses a whole spectrum of hazardous materials that can range from highly reactive chemicals to toxic gases. How does it categorize these? What's the general approach to safety given such diverse risks?
That's a really important question. How do you manage such diverse risks with a unified approach? The code works by defining specific protection levels for buildings or parts of them, based on the quantity and hazard of materials stored or used within.
Okay, different levels of danger.
Right. For example, protection level 1 applies to materials with an extreme detonation hazard, stuff that could explode with incredible force.
Like actual explosives.
Explosives, yes. Also, class 4 oxidizers, so unstable they can actually explode on their own. Or pyrophoric materials, things that burst into flames the moment they touch air. These are the most dangerous.
Yikes.
Protection level 2 deals with deflagration hazards. That's rapid burning or accelerated burning. Includes class 1, 2, or 3A, flammable liquids in open containers or under pressure, flammable gases, cryogenic liquids.
Still very dangerous, but not quite detonating.
Right. The higher the hazard level, the more stringent the requirements. Can include specific explosion control methods like venting or suppression systems. This tiered approach ensures safety measures are proportional to the risk.
So the classification based on hazard level determines the specific safety measures required. It's not just a blanket rule for all hazardous materials.
Exactly. Safety measures are tailored, and the code mandates that buildings or portions thereof requiring any of these protection levels 1 through 5 and covering everything from highly explosive down to moderately hazardous shall be protected by an approved automatic fire sprinkler system. Underscores the fundamental role of active fire protection, like sprinklers, for high-risk materials. It shows a one-size-fits-all approach isn't enough. Safety measures are meticulously tailored.
And how do they account for unforeseen events or external incidents possibly impacting these hazardous materials? It sounds like they even think about potential chain reactions.
The code takes a remarkably proactive stance on this. While it generally assumes a single hazardous material release from a single location,
Okay.
it clarifies that this shall not preclude the evaluation of multiple design scenarios. And what's fascinating here is it specifically addresses incidents impinging on hazardous materials.
Meaning things hitting the hazardous area.
Exactly. It assumes that a fire, explosion, hazardous materials release, or external force that creates a dangerous condition has the potential to impinge on hazardous materials being stored, handled, or used.
So like a truck crashing into a storage shed.
Or a fire starting nearby. It shows a sophisticated, proactive approach. Considers potential chain reactions, not just isolated incidents. How an initial event could affect the hazardous materials, leading to a much bigger, more dangerous emergency. It's about preventing that domino effect.
So they're always thinking about the worst case, even if it's an external trigger. What about outdoor storage or handling of these materials? Are there specific buffer zones or maybe alarm requirements for that?
Yes. For outdoor dispensing or use areas, the code mandates the surrounding area shall be kept clear of combustible materials and vegetation for a minimum distance of 30 feet.
Creates a defensible space.
A critical defensible space.
Right.
Reduces the chance of a nearby fire spreading to the hazardous materials. And if you're transporting highly hazardous materials, specifically those with an extreme or severe hazard ranking through corridors or exit enclosures,
Yeah.
there must be an emergency telephone system, a local manual alarm station, or an approved alarm-initiating device at not more than 150-foot intervals and at each exit throughout the transport route.
So people can raise the alarm quickly if there's a spill during transport.
Exactly. And the alarm must go to an approved central, proprietary, or remote station service or constantly attended on-site location, and also trigger a local audible alarm. Immediate notification for rapid response when the highest risks are in transit.
It sounds like a strong warning about mixing dangerous materials, even if they aren't actively being used together. Is there a specific prohibition against storing incompatible hazardous materials next to each other?
Yes. The appendix contains a really critical note on this. It states that the indiscriminate mixed storage of materials that have a high toxicity or high reactivity hazard that are also flammable liquids is a practice that could result in either a catastrophic release of toxic materials or an explosion.
Wow, so mixing the wrong things could be disastrous.
Absolutely. It highlights the complex chemical interactions you have to consider, not just individual properties. A strong directive for careful segregation, understanding chemical compatibility, preventing unforeseen, highly dangerous reactions. It's a classic example of how seemingly stable materials can become extremely hazardous when combined. Need that chemical expertise.
Fire hazards aren't just about liquids and gases. Even decorative items can pose a surprising risk, especially during holidays. What does the code say about things like Christmas trees or other vegetation in public spaces?
This raises that important question. How do you balance aesthetics, tradition, with safety? The code addresses this pretty directly.
How?
First, it defines fire retardant as a liquid, solid, or gas that tends to inhibit combustion when applied on, mixed in, or combined with combustible materials.
Okay.
For decorative vegetation, including lights, their fire retardant shall be demonstrated in an approved manner. So a Christmas tree, for example, must be treated to resist ignition, slow flame spread, and this must be proven effective.
Can't just say it's treated.
Nope. And a very common sense rule, often overlooked. Vegetation in Christmas trees shall not obstruct corridors, exit ways, or other means of egress. Crucial for keeping escape routes clear.
Makes sense.
Even the lighting is regulated. Only listed electrical lights and wiring shall be used on natural or artificial combustible vegetation. Ensures the electrical parts aren't an ignition source.
Yes.
And interestingly, electrical lights shall be prohibited on metal artificial trees.
Why is that? Shock hazard.
Likely due to electrical shock or shorting hazards, yeah. These details show how the code extends to seemingly everyday items, illustrates its pervasive reach in ensuring public safety, even down to holiday decorations.
Okay, so from holiday decorations to industrial buildup, it seems nothing escapes the code's watchful eye. I imagine places like spray booths where paint residue just seems to collect everywhere. That must be a constant battle for fire safety. Does the code really get down to telling them to, clean up?
Oh, it absolutely does. And for excellent reason. It's not just a suggestion. The code mandates that all spray areas shall be kept free of the accumulation of deposits of combustible residues.
Because that residue is fuel.
Exactly. All that paint mist, dust from sanding, it's essentially fine fuel just waiting for a spark. This is a constant maintenance task.
Right.
While combustible coverings, thin paper, plastic, etc., and strippable coatings are allowed to facilitate cleaning operations, make it easier to remove the gunk.
Yeah.
If residue accumulates to excess in booths, duct or duct discharge points, or other spray areas, then all spraying operations shall be discontinued until conditions are corrected.
They have to stop work.
Have to stop. Emphasizes that proactive cleaning isn't just good practice, it's mandatory. Operations must cease if it's not met. A direct example where operational diligence impacts safety, prevents fuel buildup that could lead to a rapid, intense fire, literally keeps operations from blowing up.
Sprinkler systems are often the first thing people think of when it comes to fire safety in buildings. They're everywhere in commercial spaces, and for good reason. What are some of the key regulations for these vital systems?
Automatic sprinkler systems are indeed foundational. They're considered one of the most effective means of fire protection, often stopping fires before the fire department even gets there.
Huge impact.
Huge. The code details their installation and maintenance extensively. For large existing residential board and care facilities, for instance, if a sprinkler system is installed, whether covering the whole building or just part, it shall be installed in accordance with Section 13.3, which lays out all the detailed technical requirements. The code also specifies the duration of water supplies shall be as required.
Ensuring enough water?
Sufficient and sustained water supply to fight a fire, based on the specific hazard level and occupancy. It's not just about having sprinklers, but ensuring they have the water pressure and volume needed for the duration. Can't run out mid-fire.
That makes sense. But what if a building's use changes? Or they start storing different, maybe more hazardous materials than it was originally designed for? Does that impact the sprinkler system, or is it just a one-time installation deal?
That raises a really important question. Are fire protection systems static? And the answer is absolutely not. The code makes that very clear. The building owner or occupant shall not make changes in the occupancy, the use or process, or the materials used or stored, without evaluation of the fire protection systems for their capability to protect the new occupancy, use, or materials.
So you have to reevaluate.
Absolutely critical. A system designed for a low-hazard office might be totally inadequate for, say, a new warehouse storing high-hazard goods like aerosols or plastics.
Right.
The evaluation must consider things like occupancy changes, such as converting office into warehousing, or process or material changes, such as metal stamping of molded plastics. This means the responsibility for maintaining system effectiveness is dynamic, continuous, not a one-and-done certification. The protection must evolve with the building's use.
So the responsibility for maintaining system effectiveness falls squarely on the owner. How does the AHJ ensure this ongoing compliance? Is there a lot of record keeping involved to prove that due diligence is happening?
Absolutely. Documentation is key to this ongoing responsibility. Records of inspections, tests, and maintenance of the system and its components shall be made available to the AHJ upon request.
And they need specifics.
Not just informal notes, no. The records must specifically indicate the procedure performed, for example, inspection, test, or maintenance, the organization that performed the work, the results, and the date.
Okay, detailed logs.
Very detailed. Furthermore, these records shall be maintained by the owner, and crucially, original records shall be retained for the life of the system.
For the life of the system, wow.
Yeah. Ensures a complete, continuous history. System performance, modifications, maintenance, provides full accountability, a baseline for future assessments. This rigorous record-keeping lets the AHJ track compliance and system integrity over decades.
What happens if a sprinkler system needs to be taken out of service, even temporarily, for maintenance or repair? Surely that creates a significant hazard if there's a fire then.
It absolutely does create a risk, and the code has strict protocols for impaired equipment. This includes vital systems like sprinklers, standpipes, fire pumps, water storage tanks.
Okay?
For any pre-planned impairments, meaning you know it's going to happen, they shall be authorized by the impairment coordinator.
A designated person.
Typically a designated, qualified individual responsible for managing such shutdowns. You can't just shut off a sprinkler system without proper authorization. Careful planning acknowledges the significant risk involved.
Right.
And it's an interesting detail. During new construction, if sprinklers are required for safety to life, the building shall not be occupied until the sprinkler installation has been entirely completed and tested.
No moving in until the sprinklers work.
Generally, yes. Unless specifically permitted for lower floors, while upper floors are still under construction under strict conditions, reflect the high importance of immediate continuous protection. An unsprinklered, occupied building poses an unacceptable risk.
And a detail that might seem minor but could have a big impact. Hospital curtains and their proximity to sprinkler heads. Is that really something the code considers? Seems very specific.
Yes, it's a nuanced detail, but it highlights the extreme level of granularity and the complexity of system design. For the proper operation of sprinklers, cubicle curtains and sprinkler locations need to be coordinated.
Why? They block the water.
Exactly. Improperly designed systems might obstruct the sprinkler spray from reaching the fire or might shield the heat from the sprinkler, meaning a poorly placed curtain could literally stop the sprinkler from activating or prevent water from reaching the fire.
Turning a small fire into a big one.
Precisely. The code offers specific options to avoid this. Hanging curtains 18 inches below the sprinkler deflector, using specific mesh top panels that let water through.
Ah.
It illustrates that even seemingly minor architectural or decorative elements can significantly impact critical life safety systems. Fire safety is a complex interplay of many factors. Small details can have major implications.
Fire alarms are critical for alerting occupants, getting people moving. What does the code say about maintaining these systems and how they communicate information effectively, especially during an emergency?
To ensure operational integrity, a fire alarm system shall have an approved maintenance and testing program. It's not a set-it-and-forget-it system at all. It requires rigorous, regular upkeep checking batteries, sensors, connections, and a critical provision addresses system downtime. If a required fire alarm system is out of service for more than 4 hours in a 24-hour period, the AHJ shall be notified, and the building shall be evacuated, or an approved fire watch shall be provided for all parties left unprotected until the fire alarm system has been returned to service.
So you can't just leave it broken overnight.
Absolutely not. Emphasizes that a non-functional alarm system creates an immediate, unacceptable risk, requires immediate compensatory measures.
A fire watch is a designated person, right? Someone physically walking around looking for fire.
Correct. A fire watch is the assignment of a person or persons to an area for the express purpose of notifying the fire department, the building occupants, or both of an emergency, preventing a fire from occurring, extinguishing small fires, or protecting the public from fire or life safety dangers.
Fills the gap when the tech is down.
Exactly. Provides human vigilance, immediate response capabilities. Critical when automated systems fail or are temporarily unavailable. Puts human eyes on the problem.
How do these systems tell responders where the fire is, especially in a large, complex building? Is it just a general alarm or more specific? Knowing the location must be crucial for firefighters.
You're absolutely right. Precision is key. The code mandates specific enunciation means basically how the system announces the alarm location. These must be readily accessible to responding personnel and located as required by the AHJ to facilitate an efficient response.
Speed and precision.
Right. For systems serving multiple areas or floors, they shall identify the zone of origin of the alarm initiation by enunciation or coded signal.
So it narrows it down.
Allows firefighters to quickly pinpoint the general area, rather than searching an entire building. And for visual enunciators, the panels with flashing lights, they shall be capable of displaying all zones in alarm simultaneously, or at least indicating other zones are alarming.
Okay.
This crucial detail enables rapid identification of the fire's location, significantly impacts response time, helps deploy resources effectively, saves lives and property.
And what about the wiring itself for these systems? Is it monitored for issues like a break in the circuit? Because that could render the alarm useless without anyone knowing. Yeah, sounds terrifying.
Yes, a very important detail. It's called monitoring integrity of installation conductors and other signaling channels.
Sounds important.
It is. Unless specific exceptions apply, all means of interconnecting equipment, devices, and appliances and wiring connections shall be monitored for the integrity, so that the occurrence of a single open or a single ground fault condition and their restoration to normal shall be automatically indicated within 200 seconds.
So it tells you if there's a wiring problem.
A critical self-diagnostic feature ensures the system is always ready to transmit an alarm, even if there's a problem with its internal wiring.
Are there exceptions?
There are specific practical exceptions, like for an alarm notification appliance installed in the same room with the central control equipment if the wires are protected, or for a trouble signal circuit itself, or interconnection between listed equipment within a common enclosure. Acknowledges scenarios where fault risk is minimal or immediately obvious, but the general rule is continuous monitoring for reliability.
What about the physical placement of automatic detectors, like smoke detectors? Does their location matter beyond just being on the ceiling? I imagine airflow or other things could affect them.
Proper placement is absolutely essential for effectiveness. The code mandates that for automatic detectors, ceilings necessary for the proper actuation shall be maintained, meaning modifications or obstructions can't compromise detector function.
Right.
For smoke detectors in high air movement areas like near a powerful HVAC vent,
Yeah.
they shall not be located directly in the airstream of supply registers.
The air could blow the smoke away.
Exactly. Could prevent smoke from reaching them, delaying activation. The specific spacing for detectors shall be in accordance with NFPA 72, another specialized standard with detailed guidance for optimal coverage. Shows the scientific rigor. And to combat nuisance alarms for detectors causing unwanted alarms, they should be tested at their lower listed range. Detectors that activate at less than this level should be replaced.
Get rid of the faulty ones.
Ensure systems are not only present, but reliable, calibrated correctly. Avoids those nuisance alarms that lead to complacency. You don't want people ignoring alarms because they're always going off falsely.
Fire hydrants seem straightforward, but they're literally the lifeline for firefighters, providing the water needed for major blazes. What's covered there in the code beyond just making sure they're, painted red?
A fire hydrant is defined as a valved connection on a water supply system having one or more outlets, and that is used to supply hose and fire department pumpers with water, the critical interface.
Okay.
And a crucial detail. You need a permit to use a fire hydrant or operate a water control valve intended for fire suppression purposes.
Why a permit?
Prevents unauthorized use, accidental closures, tampering, things that could compromise fire department operations or disrupt the public water supply when it's most needed. Ensures the supply is always available and under proper control for fire suppression. You can't just tap into it for a block party without permission.
And private fire service mains, like the ones feeding sprinkler systems on a large commercial property or industrial complex. Are they subject to the same scrutiny, even if they're not public infrastructure?
Absolutely. A private fire service mains installed in accordance with this code shall be properly maintained to provide at least the same level of performance and protection as designed.
Owner's responsibility again.
Explicitly, the owner is responsible for maintaining this system and keeping it in good working condition. Furthermore, it shall be inspected, tested, and maintained in accordance with NFPA 25.
Another specific standard.
Right. NFPA 25 focuses entirely on testing and maintenance of water-based fire protection systems. Ensures the water supply needed for a major fire is always available and functional, not just when initially occupied.
Got it.
For instance, in massive lumber yards, the hydrant system isn't just for a quick splash. The code mandates they must deliver an enormous volume of water enough for 4 powerful fire hoses simultaneously. Ensures firefighters have the sustained supply for such a fuel-rich blaze.
Everyone knows what a fire extinguisher is. But what are the details for their use and maintenance in a code setting? Seems like more to it than just hanging one on a wall and hoping for the best.
Portable fire extinguishers are indeed the first line of defense in many situations, and the code ensures they are ready and appropriate.
Okay.
It requires that listed portable fire extinguishers shall be provided in such quantities, sizes, and types as could be needed for the special hazards of operation and storage.
So the right kind and enough of them.
Exactly. Not just an extinguisher. The right type, Class B for flammable liquids, Class K for cooking oil fires, etc., and enough of them for the specific risks present. Also, they need regular checks. Maintenance shall be performed annually, ensuring they remain operational.
And they undergo serious testing, don't they? I've heard about hydrostatic testing, which sounds pretty intense, like pressure testing.
Yes, exactly. Rigorous hydrostatic testing. It's essentially a pressure test to ensure the cylinder can safely hold its contents without rupturing. For example, nitrogen cylinders, argon cylinders, carbon dioxide cylinders, or cartridges, used as an expellant for wheeled fire extinguishers and carbon dioxide extinguishers, shall be hydrostatically tested every 5 years.
Regular checks.
But here's an interesting detail. Stored pressure water extinguishers with fiberglass shells, pre-1976, are prohibited from hydrostatic testing due to manufacturer's recall.
Ah, so codes adapt to recalls.
Highlights how codes adapt based on product safety issues. Ensures older equipment doesn't become a hazard. Sometimes an old extinguisher is just too dangerous to keep around and needs to be removed.
So certain types of extinguishers are just condemned rather than repaired or retested.
Yes, a cylinder or shell shall not be hydrostatically tested, but shall be condemned or destroyed by the owner or at the owner's direction if it has certain flaws.
Like what?
If it has repairs by soldering, welding, brazing, or use of patching compounds, or if the cylinder threads are worn, corroded, broken, cracked, or nicked, or if there's significant corrosion that has caused pitting.
Basically, if it's damaged or compromised.
Right. Ensures only structurally sound extinguishers remain in service. A failed extinguisher during an emergency could be disastrous. Injure the user. Make things worse.
Where should extinguishers be placed? Especially in high-risk areas like fueling stations or airports, does the code specify optimal locations for quick access?
Placement is critical for accessibility and effectiveness. At motor fuel dispensing facilities, extinguishers shall be provided according to the extra high hazard requirements for Class B hazards for flammable liquid fires.
Right.
Except that the maximum travel distance to a 80 BC extinguisher shall be permitted to be 100 feet. For airport terminal buildings, they shall be provided throughout the building.
Yeah.
For those used outside, like at aircraft fueling areas, they should be located upwind, not over 100 feet from the aircraft being serviced.
Upwind, so you're not spraying into the wind.
Exactly. And, critically, extinguishers shall be kept clear of elements such as ice and snow, and if in enclosed compartments, their location must be marked clearly in letters at least 2 inches high.
Visible and accessible.
Not just present, but accessible, functional, and visible in all conditions, even bad weather. Every second counts.
And a very specific warning about certain types of extinguishers in kitchens, I saw. That sounds like a really important detail for anyone working with commercial cooking equipment where grease fires are a constant threat. Needs careful handling.
Yes, this is an important safety warning. Highlights a specific dangerous design flaw identified through, sadly, tragic incidents.
Oh, no.
The code explicitly states, Class K fire extinguishers equipped with extended wand-type discharge devices that can permit subsurface injection into hot cooking media are not safe for use.
Subsurface injection, like sticking the wand into the hot grease.
Yes, And the reason is critical. Subsurface injection causes a thermodynamic reaction comparable to an explosion, which can cause serious injury or death and can contribute to the rapid spread of fire.
It makes the grease explode.
Causes a violent eruption rather than suppression. This highlights a specific, dangerous misuse or design flaw. The code is explicit to prevent severe injuries. Key detail for anyone in commercial kitchens or around deep-fat fryers: avoid that wand.
Beyond the big ones like sprinklers and alarms, what other critical systems are covered by these codes? Things people might not immediately think of as fire protection equipment, but are still vital, because I imagine it's all interconnected.
You're right, there's a wide array of interconnected systems contributing to overall fire safety. Let's look at emergency power, for example.
Backup generators.
Exactly. Stationary generators for emergency use or standby power required by this code shall be installed in accordance with NFPA 110, Standard for Emergency and Standby Power Systems.
Another specialized standard.
Yep. Ensures proper installation for reliability. Newly installed generators must demonstrate the capacity to survive without damage from common and abnormal disturbances in actual load circuits.
So they have to be robust.
Vital. Because these systems power crucial life safety features during an outage, emergency lighting, fire alarms, egress systems. Without them, people could be plunged into darkness during an emergency. Directly impact safe evacuation.
What about refrigeration systems? They don't immediately strike me as fire safety equipment, but I imagine some refrigerants can be hazardous if they leak, maybe flammable or toxic.
What's fascinating here is how interconnected building systems are with fire safety. Large refrigeration systems, especially using hazardous refrigerants like ammonia.
Ammonia is hazardous.
Oh yes, toxic and flammable under certain conditions. They pose unique risks. Not just fire, but toxic release or explosion.
Okay.
They must have automatic crossover valves, providing a crossover connection to a lower pressure zone. These valves automatically relieve excess system pressure if it gets too high, prevents catastrophic ruptures.
Like a safety valve.
Right. The lowest pressure zone also needs a dedicated means of determining a rise in system pressure to a critical point. And if activated, all compressors on the affected system to immediately stop. Prevents further pressure buildup.
I'm smart.
And if the system discharges refrigerant vapor to the atmosphere, an approved treatment or flaring system might be required. Safely neutralize or burn off the hazardous gas. The appendix even suggests a water diffusion system for ammonia discharge if atmospheric release endangers life. Very specific emergency tactics.
So the detection of refrigerant leaks is also critical for these systems. And how are those systems managed once they're in place? Needs monitoring too.
Yes, refrigerant vapor detection and alarm systems are mandated, and these systems shall be powered and supervised as required for fire alarm systems.
Treated just like fire alarms.
Same criticality. They must also be remotely enunciated at an approved, constantly attended location, ensuring off-site monitoring, immediate notification of a leak. Installation and maintenance must follow manufacturer specs. Additionally, purge fans shall also respond automatically to the refrigerant concentration detection system, activating ventilation when a leak is detected. And an emergency purge control shall be provided with a manual reset only, preventing accidental deactivation.
Manual reset, okay.
The mechanical ventilation switches for these rooms must be key-operated or within a locked glass-covered enclosure at an approved location adjacent to and outside of the principal entrance. Ensures only authorized personnel control critical ventilation, prevents tampering during an incident, guarantees safe operation or shutdown. It's about containing a potentially dangerous vapor release immediately.
And commercial kitchens, with all that grease. But they must have specific fire suppression systems too, right? Beyond just portable extinguishers. But the grease fires are a whole different beast. We need something automatic.
Indeed, grease fires are intense. Fire extinguishing equipment for the protection of grease removal devices, hood exhaust plenums, and exhaust duct systems shall be provided.
A whole exhaust system.
The whole thing, from the stove to the rooftop. And cooking equipment that produces grease-laden vapors and might be a source of ignition of grease shall be protected by fire extinguishing equipment.
Yeah.
Integrated protection,
Makes sense.
a crucial safety measure. Upon activation of any fire extinguishing system for a cooking operation, all sources of fuel and electric power that produce heat shall automatically shut off.
Cuts the heat source.
Prevents reignition after initial suppression. Critical, since hot grease can easily reignite. A practical detail. A single listed detection device shall be permitted for more than one appliance if installed per its listing. Can streamline design. And crucially, before installation, complete drawings of the system installation, including the hoods, exhaust ducts, appliances, interface of the fire extinguishing system detectors, piping, nozzles, fuel shutoff devices, agent storage container, and manual actuation devices shall be submitted to the AHJ. Thorough review and approval up front.
How often do these cooking fire suppression systems need to be checked? Given the constant buildup of grease, it seems like it would require frequent, specialized maintenance.
You're exactly right. Regular maintenance is absolutely critical for these systems due to that grease buildup. Maintenance shall be made by properly trained, qualified, and certified persons or company acceptable to the AHJ at least every 6 months.
Every 6 months. By professionals.
Regular professional oversight. Vital for systems that accumulate combustible residues and can become less effective. And when cleaning the hood and ductwork, which must be done to remove combustible contaminants prior to surfaces becoming heavily contaminated.
Yeah.
Electrical switches that could be activated accidentally shall be locked out during cleaning. Safety measure for the cleaners. Also, components of the fire suppression system shall not be rendered inoperable during the cleaning processes unless the service is performed by properly trained and qualified persons who can implement alternative safety measures. Ensures continuity of protection or safe work practices are always in place, even during cleaning. Operational diligence built right into the code.
Construction sites often look like, well, like a disaster waiting to happen sometimes. So many changing variables, materials everywhere, temporary structures. What special rules are in place during these phases to prevent fires, given how dynamic and risky they are?
Construction and demolition sites are indeed dynamic environments. Unique, elevated hazards require specific fire safety protocols.
Okay.
For instance, if trash chutes are used, which can act like a chimney for fire,
Right, spread it vertically.
an approved safety plan shall be submitted to the AHJ. Critical for managing waste, preventing vertical fire spread. Storage of flammable liquids is also strictly controlled. Storage of Class 1 and Class 2 liquids shall not exceed 60 gallons within 50 feet of the structure.
That buffer zone again.
Vital buffer. The site also needs an overall construction or demolition fire safety program developed to address essential items.
Security.
Yep. Includes ensuring security fences shall be provided where required by the AHJ, and entrances to the structure shall be secured where required by the AHJ. Minimizes unauthorized access, arson risk, a significant concern on construction sites.
How do they handle fire alarms on a site that's constantly changing? New sections being built or demolished. You can't just install a permanent system from day one and expect it to cover everything or even work reliably.
That's a key challenge, and the code has pragmatic solutions. It requires a readily available public fire alarm box near the premises, telephone service to the responding fire department, or equivalent facilities.
So always a way to call for help.
Ensures that despite the temporary nature, there's always an immediate means to alert emergency services. Furthermore, instructions shall be issued for the immediate notification of the fire department. And the local fire department number and site address shall be conspicuously posted near each telephone.
Clear contact info.
Ensures it's always accessible. And for certain hazardous demolition sites, where risks are particularly high, qualified personnel shall serve as an on-site fire watch.
Human eyes again.
Reinforces the importance of human vigilance when other systems may be incomplete or temporarily compromised.
What about specialized construction methods, like torch-applied roofing? That involves open flames directly on a roof. This sounds inherently dangerous. How is that managed?
You're absolutely right. It's a high-risk activity.
Yeah.
Notorious for starting fires if not done carefully. Torch-applied roofing systems involving open flames and combustible materials like asphalt shall be installed in accordance with Chapter 7 of NFPA 241, Standard for Safeguarding Construction, Alteration, and Demolition Operations.
A whole separate standard just for construction safety.
Indicates there's an entire specialized standard just for these processes, highlighting the unique dangers. And for tar kettles used in roofing those big, hot vats of tar, general provisions apply. These kettles shall not block exits, means of egress, gates, roadways, or entrances, and must be not closer than 10 feet from exits or means of egress.
Keep them away from escape routes.
Prevents them obstructing escape or firefighter access. For their fuel systems, LP gas cylinders must be secured to prevent accidental tip-over, and fuel containers must be constructed and approved for the use for which they were designed. These specific details highlight how the code addresses unique construction hazards, emphasizing prevention, control of ignition sources, and fuel, because one spark on a roof can quickly become a raging fire.
Carnivals, fairs, concerts, theaters, places where huge crowds gather, these must have very specific fire safety rules, right? Given the potential for rapid chaos in an emergency, Crowd management is a whole different ballgame.
Absolutely. Managing crowd safety is paramount in these environments. For carnivals and fairs, a permit is required. Recognizes the temporary nature inherent risks. There are specific requirements for concession stands involving cooking, common ignition sources. They shall have a minimum of 10 feet of clearance on two sides and shall not be located within 10 feet of amusement rides or devices.
Keeps cooking fires away from the crowds on rides.
Prevents a cooking fire from quickly spreading to an area with high occupancy, potential entrapment. And a method of notifying the fire department in the event of an emergency shall be provided. Telephone, alarm system connected to the fire department ensures immediate emergency communication.
What about temporary structures like tents and grandstands? Common at these events, but they're not as robust as permanent buildings. What are the rules there?
For tents, specific allowances and restrictions apply. Tents, each not exceeding 1,200 square feet,
Mm.
and located in fairgrounds or similar open spaces, shall not be required to be separated from each other, provided that safety precautions meet the approval of the AHJ.
So small tents can be close together, maybe?
With AHJ approval. However, the AHJ has discretion on the placement of tents relative to other structures, considering occupancy, use, exposure. A crucial rule for tents. The ground within any tent, and for not less than 10 feet outside of such a tent, shall be cleared of all flammable or combustible material or vegetation.
Creates a fire break around the tent.
A critical, defensible space. Prevents a small ground fire engulfing the structure. For portable grandstands, all bearing surfaces shall be in contact with each other to ensure structural stability.
Don't want them collapsing.
No. And spaces underneath the grandstand shall be kept free of flammable or combustible materials, unless protected by an approved, supervised automatic sprinkler system. Prevents those hidden spaces becoming fuel loads.
Don't want a fire starting under the bleachers.
What about places like movie theaters or auditoriums where people are seated, focused on a performance? How do they ensure people know how to get out quickly, especially if they're immersed in a show or maybe unfamiliar with the layout? Good question. In assembly occupancies with occupant loads exceeding 300 where there are non-continuous programs, theaters, movie theaters, auditoriums,
Yeah.
an audible announcement shall be made or a projected image shall be shown prior to the start of each program that notifies occupants of the location of the exits to be used in case of a fire or other emergency.
The pre-show safety announcement.
Exactly. Simple but incredibly effective. Ensures people know their escape routes, especially if unfamiliar or distracted. This requirement doesn't apply to assembly occupancies in schools where used for non-public events, assuming student staff know the building.
Right.
Emphasizes direct, timely information in high occupancy settings where the audience changes constantly.
And the idea of a fire watch applies here too, right?
Yeah.
Even with all these systems, human vigilance is still important, especially for a large, potentially chaotic crowd.
Yes. The code notes that while there's no general requirement for patrols, a system of well-trained patrols or fire watchers should be maintained in every place of assembly where fire hazards might develop.
Where are they most needed?
Particularly relevant for spaces underneath grandstands and the areas inside and outside tents and air-supported structures areas prone to hidden hazards or quick fire spread.
Okay.
Fire watchers serve to detect incipient fires and to prevent an accumulation of materials that will carry fire. Provide immediate response, mitigation before a small incident becomes a catastrophe. Highlights that human vigilance remains critical, even with advanced systems, especially in transient environments. They are the eyes and ears on the ground.
Fueling stations, airports, marinas. These are places where highly flammable materials are constantly being handled, often with moving vehicles or vessels involved. What are the specific safety requirements for them, given that high constant risk?
Motor fuel dispensing facilities or gas stations definitely require permits. Detailed plans and specs must be submitted prior to the installation or construction.
Okay.
These sites have very strict minimum separation requirements for above-ground tanks. Specifies precise distances from buildings, dispensing devices, property lines based on tank capacity and type.
More distance for bigger tanks.
Generally, yes. For instance, a protected above-ground tank, up to 6,000 gallons, needs 5 feet from a building, 0 feet from the dispenser, 15 feet from a property line. Fire-resistant tanks need more distance. Other tanks meeting NFPA 30 even further. Illustrates the graded risk, the increasing buffer needed.
Are there specific requirements for the tanks themselves to withstand fire? Or for leak detection? Because a leaking fuel tank sounds like an absolute nightmare.
Yes. The construction providing the required fire-resistant protection must prevent release of liquid, failure of the primary tank, failure of the supporting structure, and impairment of venting for a period of not less than 2 hours when tested under specific fire conditions.
So they have to hold up in a fire for 2 hours.
Ensure integrity during a prolonged fire exposure. For remote or submersible pumps transferring liquids from storage to dispensers, a listed leak detection device must be installed on the discharge side.
To catch pipe leaks.
Right. This device will provide an audible or visible indication if the piping or a dispenser is leaking. It must be checked and tested at least annually. Ensures early detection of potentially dangerous leaks.
What are the basic fire controls during actual fueling operations? I always see those no smoking signs at gas stations, obviously, but what else is required?
Those no smoking signs are directly from the code, and for good reason. At fueling areas, smoking materials, including matches and lighters, shall not be used within 20 feet of areas used for servicing fuel systems, or receiving or dispensing of Class 1 and Class 2 liquids.
20-foot rule.
Yep. Additionally, the motors of all equipment being fueled shall be shut off during the fueling operation, except for emergency generators or pumps where a continuous operation is essential. Fundamental ignition source control.
Makes sense.
For mobile fleet fueling, where fuel trucks refuel vehicles on site, like at a construction site, it's only permitted if approved by the AHJ. The dispensing hose shall not exceed 50 feet in length, and the dispensing nozzle shall be a listed automatic closing type without a latch-open device.
Yeah.
Prevents overfilling.
No propping the handle open.
Right. Nighttime deliveries shall only be made in areas deemed adequately lighted by the AHJ. These details prevent overfilling, spills, ensure safe operations, especially in less controlled environments.
And airports and marinas have unique fueling challenges with aircraft and boats. Large volumes, confined spaces sometimes. I imagine static electricity would be a huge concern there too, maybe even more so.
Yes, very specific and stringent requirements apply. For aircraft fuel servicing, a no smoking sign shall be posted prominently in the cab of every aircraft fuel servicing vehicle.
Right in the truck cab.
And smoking equipment such as cigarette lighters and ashtrays shall not be provided. If a vehicle includes such equipment, it shall be removed or rendered inoperable.
Get rid of temptation.
Exactly. There's a particular concern with static electricity during fueling. Ordinary plastic funnels or other non-conducting materials can increase static generation, and using chamois as a filter is extremely hazardous, highlights unseen risks that could ignite fuels.
Wow.
Even electric hand lamps used in the immediate proximity should be of the type approved for use in Class I, Division 1, Group D, hazardous locations, meaning specially designed not to cause sparks in a flammable atmosphere. Very specific safety for specialized environments.
What about boats and marinas? Those wooden docks, fiberglass boats, all that fuel. Seems like a recipe for a rapid fire spread if something goes wrong.
Absolutely. For marinas and boatyards, buildings over 5,000 square feet shall be protected by an approved automatic fire extinguishing system. Crucially, open flame heaters shall not be used in boat storage areas.
No space heaters near the boat.
Right. And the use of blowtorches or flammable paint removers shall be prohibited unless permitted by NFPA 303, the specialized marina standard. Also, the use of gasoline or other flammable solvents for cleaning purposes shall be prohibited.
Using gasoline to clean? Bad idea.
Very bad. For boats dry stored for the season or stored indoors, precautions must be taken, like ensuring fuel tank shutoff valves are closed. These regulations recognize the significant flammability of boat fuels and materials, and the potential for a small spark to cause a large-scale fire, especially tough in marine environments.
Let's deep dive into storage facilities for a bit. Warehouses, lumber yards, even places that store tires.
Yeah.
They all have unique risks and, I assume, unique safety requirements in the code because you can't fight a tire fire the same way you fight a wood fire, right, Greg?
You're absolutely right. And what's fascinating here is how the code anticipates very different fire behaviors based on the stored material, leads to highly tailored regulations.
Okay, like lumber yards.
For lumber and wood panel product storage yards, access by unauthorized persons shall be prohibited. Storage areas shall be enclosed with a fence equipped with effective gates to allow entry of fire department apparatus. Controls access, ensures firefighters get in quickly. Yard areas shall be separated from plant operations and other structures by a clear space permanently available for firefighting operations. A critical fire break. In forested areas, a wider clear space is required. A reliable means for prompt transmission of fire alarms is also necessary.
Why are lumber yard fires so bad?
The appendix notes the problems. Large undivided stacks, congested storage, delayed detection, inadequate fire protection, ineffective firefighting tactics. They're notoriously tough. sheer fuel load, difficulty penetrating the stacks.
Right.
This is why heights in excess of 20 feet seriously restrict effective extinguishing operations in log piles. Hard to get water deep inside from the side.
What about tire storage? That seems like a particularly unique challenge given how tire fires behave. They burn forever and produce nasty smoke.
Tire fires are indeed notoriously difficult to extinguish. Burn for ages, incredibly toxic smoke. The code even defines specific firefighting strategies like bury it.
Burying the fire?
A tire pile is buried with soil, sand, gravel, cement dust, or other cover material. Illustrates the extreme measures sometimes needed when water or foam doesn't cut it.
Wow.
For stored tires, specific spatial requirements manage fire spread. Tires next to a wall shall not extend more than 25 feet from the wall. If stored on tread, upright, the pile dimension not more than 50 feet. And the width of the main aisles between piles shall be not less than 8 feet.
Aisles for access and separation.
Vital for fire containment, firefighter access. Additionally, storage clearance from roof structures shall be not less than 18 inches. Prevents fire spread to the roof, allows sprinklers to work.
And idle pallets are a common hazard in warehouses. Just stacked up everywhere, waiting to be used. How does the code address them? They seem like they'd burn really fast.
Idle pallets, especially wood, present a significant fire hazard, basically kindling for a warehouse fire.
Right.
The code specifies if high expansion foam is used to protect them, it shall have a fill time of not more than 4 minutes. Needs to flood the area quickly. These foam systems are automatic in operation, triggered by detectors that must be listed and shall be installed at the ceiling at not more than 1/2 the listed spacing. Ensures rapid detection. Also, detection systems, concentrate pumps, generators, essential components shall have an approved standby power source.
Redundancy for reliability.
Ensures the system works when needed, even during a power outage. Importantly, a fire watch shall be maintained when the sprinkler system is not in service. Emphasizes constant need for protection, even during downtime. Highlights the serious risk posed by even seemingly innocuous stacks of pallets. Significant fuel load.
Aerosol cans are everywhere. Household cleaners, spray paints. How are they handled in storage? Given their pressurized, often flammable contents. Because a room full of exploding aerosol cans sounds like an absolute nightmare scenario.
Aerosol products are actually quite carefully classified, based on their chemical heat of combustion, from level 1, lowest hazard, up to level 3, which is greater than 13,000 BTU per pound, represents the highest hazard, almost like a small projectile bomb in a fire. Manufacturers must ensure that all cartons or packages are identified on at least one side with the classification. Clear labeling is critical for risk assessment, proper storage.
So you know what you're dealing with.
Right. Building construction for aerosol storage includes keeping openings in firewalls or fire barriers to a minimum. And these openings must be protected by automatic closing or self-closing fire doors or dampers.
Fire compartmentation, boxing it in.
Exactly. Fire doors installed per NFPA 80, dampers per NFPA 90A, ensures fire containment. Additionally, means of egress shall comply with. NFPA 101 guaranteeing safe escape roads. This detailed approach ensures storage facilities for these common but potentially dangerous products are built to contain potential fires and protect egress.
What about historic buildings and cultural resources? Museums, old libraries, they can't just be retrofitted like modern buildings with all the latest fire safety systems, can they? You can't just slap a sprinkler system onto a priceless fresco or inside a delicate historic structure.
This raises that important question, balancing preservation and safety. And the code explicitly acknowledges this unique challenge. It's a tough balance.
So what's the solution?
It states that historic buildings shall comply with this code, or with the provisions of NFPA 914, Code for Fire Protection of Historic Structures.
Ah, a dedicated code for historic buildings.
Exactly. Similarly, for buildings that store or display cultural resources, including museum or library collections, they can comply with NFPA 909, Code for the Protection of Cultural Resources.
Another specialized one.
Right. This provides essential flexibility. Recognizes some structures have irreplaceable architectural or historical significance. Strict adherence to conventional codes might be impractical or damaging. Instead, they use specialized standards designed to achieve equivalent safety through alternative, often creative solutions sensitive to the building's unique character and preservation needs. Pragmatic approach, safety without destroying history.
And daycare homes, very specific rules, I'm sure, given the vulnerability of the little ones. What stands out there?
Indeed, especially for vulnerable populations. For new daycare homes with more than 3, but not more than 12, clients, Specific requirements of NFPA 101, the Life Safety Code, apply.
Okay.
A fascinating detail for these facilities. Fire prevention inspections shall be conducted monthly by a trained senior member of the staff.
Monthly in-house inspections.
Yep. After which a copy of the latest inspection report shall be posted in a conspicuous place in the daycare facility. And it shall be the duty of site administrators and staff members to inspect all exit facilities daily,
Daily checks on exits.
to ensure that all stairways, doors, and other exits are in proper condition. Emphasizes daily vigilance, transparency within the facility itself, not just relying on infrequent external inspections.
Makes sense for kids.
Also, for healthcare occupancies, portable space heating devices shall be prohibited unless used only in non-sleeping staff and employee areas. Common household hazard restricted here due to vulnerable patients. Another detail. Container size and density shall not be limited in hazardous areas for large mobile soiled linen or trash carts if they are kept in a protected hazardous area when unattended.
The general purpose warehouse and mini storage definitions are very precise. Why is that precision so important given the huge range of things people might store in them?
These precise definitions are critical because they dictate the specific level of fire protection required, sprinkler requirements, fire barriers, other safety measures. It all hinges on the definition.
Okay.
A general-purpose warehouse is a separate detached building or portion used only for warehousing-type operations. This is distinct from a mini-storage building, which is partitioned into rented areas for personal business items, often with less robust internal barriers and concealed contents.
Right, you don't know what's in each unit.
Exactly. That presents a very different firefighting challenge than a large, open warehouse where contents might be more uniform or visible. Understanding the exact nature of the occupancy is the first step, because ordinary, moderate hazard occupancies, which include retail, light manufacturing, warehouses with lower hazard goods, have different risks and requirements than other types of storage. Precision ensures safety measures are tailored to the actual risk, avoids overregulation and underprotection.
Okay, so all these prevention and protection systems are in place, meticulously planned, maintained, hopefully. But what happens when the worst occurs, when the fire department needs to respond? What does the code require to ensure they can actually do their job effectively and swiftly? Get to the scene, tackle the blaze.
This is such a critical link in the entire safety chain, getting help there fast. And first, it covers some surprisingly basic things like address number.
Address number?
Yeah. They must be conspicuous and legible, contrast with their background, and be Arabic numerals or alphabet letters. Might seem trivial, but clear address identification can shave crucial minutes off response times.
Especially in unfamiliar areas. Could be life or death.
Absolutely. Similarly, every outside opening accessible to the fire department that opens directly on any hoistway or shaftway.
Like an elevator shaft.
Elevator shaft, utility shaft, communicating between floors shall be plainly marked with shaftway, in red letters at least 6 inches high on a white background.
Why?
Vital for firefighter safety. Warns them of dangerous vertical openings that could be mistaken for a regular floor or window. Prevents accidental falls into shafts, a surprisingly common and tragic hazard for responders in smoky conditions.
And those designated fire lanes we see painted around buildings and complexes, how do they play into this critical access for emergency services? Seems pretty obvious, but I guess it needs spelling out.
Oh, it definitely needs spelling out. A marked fire apparatus access road shall also be known as a fire lane. And the code is absolutely clear. The required width shall not be obstructed in any manner, including by the parking of vehicles.
No parking, period.
Minimum required widths and clearances shall be maintained at all times. Additionally, facilities and structures shall be maintained in a manner that does not impair or impede accessibility for fire department operations.
So buildings can't block access either.
Right. This is crucial. If firefighters can't get their large apparatus, their equipment, close enough, everything else gets exponentially harder and slower. Connecting to hydrants, deploying ladders,
Delays the whole response.
blocking a fire lane, even for a few minutes, could directly contribute to a tragic outcome by delaying that response. It's a direct operational link to safety. Why those no parking fire lane signs are so serious.
What about larger planned building groups, especially those in more rural areas where fire department resources might be stretched thin or response times just naturally longer? Does the code offer specific guidance for them?
Yes, this is where the code really adapts to real-world limitations and different environments. For planned building groups in suburban and rural areas, Chapter 15 applies when the AHJ determines they could be impacted by factors like
Like what?
limited water supply, limited fire department resources, extended fire department response time, delayed alarms, limited access, hazardous vegetation, or unusual terrain during a fire.
So it considers the context.
Shows an adaptive approach. Acknowledges fire safety needs differ significantly based on geography, resource availability. It implies a greater need for self-sufficiency in fire protection, perhaps, or specialized planning. On-site water storage, pre-planned access routes. Emphasizes fire protection isn't just the building, but the surrounding environment and available resources too.
Beyond physical access, what about the human element? The training, the procedures, the stuff that makes a real difference in an emergency. All the systems in the world won't work if people don't know what to do when the alarm goes off.
This is the operational side of safety, absolutely paramount. For daycare occupancies, for instance, given the vulnerable kids,
Right.
written fire emergency response plans should include information for employees regarding methods, for alerting occupants, and how the fire department is to be alerted. Even with automatic systems, the plan needs backup alerting procedures by staff.
Okay.
Employees should also know how to remove clients in immediate danger to areas of safety. This detailed planning ensures everyone knows their role, especially for vulnerable populations who can't self-evacuate.
And for those working with highly hazardous materials, the training must be extensive and continuous, right? Seems like a constant learning process to stay safe around that stuff.
Absolutely. Constant learning. The code mandates persons responsible for the operation and maintenance of areas in which oxidizers are stored shall be trained in the chemical and physical hazards and compatibility of stored materials,
Know your chemicals.
and know what not to mix. The training must also cover hazard communication regulations, ensuring they understand risks, how to convey them. For very large quantities of oxidizers, over 36,000 pounds for less reactive ones, down to just 10 pounds for the most dangerous Class 4 type.
Yeah.
Personnel must be trained at the technician level, as described in NFPA 472, Standard for Professional Competence of Responders to Hazardous Materials Incidents.
Hazmat technician level, that's serious training.
Extremely specialized, recognizes the severe risks, the need for highly competent responders who understand the immediate dangers and how materials might react.
So the people handling the materials are themselves an integral part of the safety system, not just the equipment, but the trained personnel.
Yes, they are integral, absolutely. For liquid processing facilities, procedures shall be established to provide for safe shutdown of operations under emergency conditions. There must be periodic training, inspection, and testing of associated alarms, interlocks, and controls.
Testing the human and the machine.
Emphasizes the human element in maintaining automated system integrity, knowing how to respond. And critically, the emergency procedure shall be kept readily available in an operating area and updated regularly. Ensures critical info is always at hand and procedures evolve.
And finally, what about tampering with fire safety equipment? I imagine there are strict prohibitions against that, but you also need allowances for necessary maintenance. Otherwise, nothing would ever get fixed or updated. How does the code handle that balance?
What's fascinating here is the clarity of the prohibition balanced with practical needs. The code states flatly, no person shall render any portable or fixed fire extinguishing system or device or any fire warning system inoperative or inaccessible.
Don't touch it.
Direct command. Preserve safety systems, ensure they're always ready. However, it provides practical, necessary exceptions. As necessary during emergencies, maintenance, drills, prescribed testing, alterations, or renovations, these systems shall be permitted to be made inoperative or inaccessible.
Allows for essential work.
Right. But even then, there's a critical caveat. No person shall render a system or device inoperative during an emergency unless by direction of the incident commander.
Only if the boss says so during the actual event.
Exactly. Balances the need for maintenance and flexibility with the paramount importance of not compromising safety without proper authority and oversight. Highlights how codes are designed to be both stringent and practical. Allows necessary actions while preventing reckless or unauthorized tampering. A system built on trust and careful controls.
Wow, what a deep dive into the National Fire Protection Association's Fire Code NFPA 1. It's truly eye-opening to see the incredible detail, the foresight that goes into keeping us safe every single day, often without us even realizing it's happening.
Indeed.
Yeah.
It really is remarkable when you unpack it. From the seemingly simple act of clearly numbering a building
Right.
to the complex engineering behind modern sprinkler systems, the rigorous training needed for hazardous materials, the careful separation of flammable liquids. Every rule, every definition in this code builds towards a singular, profound goal: minimizing the threat to life and property from fire and other emergencies. It's a constant evolving effort to anticipate and mitigate risks, balancing those prescriptive requirements with performance-based flexibility to ensure safety in incredibly diverse environments.
So, what does this all mean for you, our listener? As you go about your day in your home, at work, out in public spaces, consider this provocative thought. How do these layers of unseen, meticulously defined safety measures, everything from the placement of an exit sign to the design of an emergency power system, how do they contribute to your peace of mind?
Hmm.
And how might your understanding of their purpose empower you to be a more informed, maybe more proactive participant in community safety? Perhaps even noticing things you never did before.
Yeah, next time you see a clear fire lane or a strategically placed fire extinguisher or even just a clear pathway in a public building, you'll know there's a whole world of science, engineering, and frankly, dedication behind its presence and maintenance.
Yeah.
It raises an important question, I think. What other hidden safety protocols are at play in your environment? And how might understanding them prompt you to ask deeper questions about the spaces you inhabit, making you a more knowledgeable advocate for your own safety and for the safety of others around you?
Thanks for joining us for this deep dive. Stay curious, stay informed, and most importantly, stay safe.